We have a saving and loading system with different save slots, all working. It is great, it's perfect, it's a little shaky the way I implemented certain things because I just want to show the examples. Today though, I want to show you how to implement some kind of meta save file. And what do I mean by that? Well, these save files that we have here hold values for our score. So we can see that we have like 40 score. If we load this save file and we try to increase our score again, we have only like 9, 10, 11, 12. If I load this one, we're up to like 30 again. We have a basic save slot system now. But what if we want to display the score and the game time that we have on those save slots, so that when we load them, we can actually, like, we know what we're loading. That is quite important, I would argue. If you haven't seen the last video, it's going to be important for you to watch that one, because everything that we're doing here will build upon what we did there. If you want the finished project file, always link down below in the description for members on YouTube and Patreons. You can get the project file and just play around with it yourself if you want that. So first things first, we want the meta save file, right? So let's make that meta save object first. This is going to be a blueprint class of type save game, and we'll just call this BP meta save. And this meta save will only hold the information that we want to display on the save file. So we don't need to load every single save file in our game in order to display data from them. In our case, that is going to be all the data that we have, because we only have the score and the game time existing in our save files to begin with. But if you have a real game, you probably have like a bunch of other information, like what things have you unlocked, what amount of money do you have in the game, that sort of stuff, which doesn't need to be displayed on the save slots themselves. Well, maybe the money does. So those will just be in the save files themselves, and the meta save file will only have a tiny fraction of the information that we actually worry about. So the way we do that is, first and foremost, we're going to be making a new blueprint structure. So if we go in here, blueprint, we can make a structure, and this will be our save game metadata. And this is going to hold all of the metadata for every single save file. So in this case, that would be something like game time, which would be a integer, and the score, because we also want to display that. Again, that is, in our case, also everything that the save game itself holds. But imagine that there's a lot of other stuff in the save game, depending on what game you're making. That doesn't need to be in here. This is only the things that we want to display visually in our save menu. Then in our meta save game blueprint, so that is this one, the save game blueprint that we just made. What we're going to do is we're going to add a variable here, which will be our save files. And the type is going to be a string, and it's going to be a map. So what a map will allow us to do is it'll allow us to give in a string, the save file's name, and give it a corresponding any type of data. In this case, that's going to be our save game metadata. So just to show you in the default values here, if I add some, what we can do is this has a save name. So this would be like save 97. And that could have then the data in it for like 80 seconds of game time and score 7, something like that. But of course, we're going to be setting that entirely programmatic, so don't worry about giving a default value. Now that we have that in place, we want to go back into our save slot stack, because this is the thing actually making the save slot and instantiating all of those buttons. And this is also the place where we load that information and set it into those little text fields. So let's go all the way back to the beginning here. After we clear the children, or before, whatever you prefer, we're going to load that meta save file. So first we want to check, does save game exist? And here we're just going to hard code in a value, and we'll call this meta save. And we'll do the same thing that we did before, which is we'll check whether or not it exists. And if it does exist, we'll just load it. If it does not exist, we'll create it. So on false, we will create save game object of type BP meta save. And we'll just quickly promote it to a variable for meta save. And if it does exist, we simply want to load game from slots. And to be safe, I'm just going to copy over this name so there's no room for typos. This does need to be the exact same thing. capitalization included. We're going to cast that then to our BP meta save so that we can set this to that variable that we just made. Again, this is just kind of what you do when you load a save game to begin with. And both of those are going to go into the for each loop. Now that we have that, let's go back to setting these texts, because now we can finally set those texts. Let's get our meta save, and we can get our save files map from that. And here we try to find an entry in that map. So what we're going to be doing is we want to find our save's name for every single save in this loop. So let's just use the same thing that we're using here, just to be consistent. You can give these different names if you really, really want to. I think that probably makes it confusing, but you're not going to be like interfacing or interacting with these names at all. This is purely programmatic. So technically speaking, since they are strings, it would be better to keep them as short as possible, because that means that they're going to be slightly more performance, but it doesn't really matter that much. So once we find that, we have our structure and we can break that, and we can set the game time, which is this one, to, let's use an append string here as well. We're going to need to make a little bit more room to make all this work. So let's just move everything a little bit more to the right. And we will give the top slot for append here game time, make sure to include a space on the end, and then we'll just plug in our game time from whatever save file that we might have just found, or maybe not. And we can just hook that up to the proper setting nodes. Now, you do technically want to actually do this at the end. So these things that have nothing to do with the finding of things in the meta save data, you can set those beforehand. And once those are set, you actually want to go into a branching node, because you only want to set these if this finding happens. So if you are trying to find, for whatever reason, you shouldn't, but if you're trying to find a string that doesn't exist, this will return false, and we won't want to set the values of these texts. Or we can set them to like a default value instead. So only do this if this is true, and then we can then just set them to like some default values otherwise, and they'll all come back to adding this thing as a child. So let's hook this up to game time, and this, I think I initially called this save location. We're going to change this to score. So this will be score 0, and this will be game time 0, and these are just going to be the default values for those texts. And of course, we pretty much just do the exact same thing here, which is we take one of these append nodes, and instead of game time, we make one for score, and we hook up the score value to it and plug that into the set text for score. Now, going back into our game instance, or wherever your save game and load game functions exist, for me that's the game instance, after we save whatever slot we're saving to, we will also want to do some stuff to do with the meta save file. So after that, we're going to does save game exist? Again, we want to check for meta save. Do be careful and just copy paste, don't type it out like I did. And effectively, we're just going to copy this setup over. Which, if you're doing that, do be aware, though, that you also actually copy over the meta save variable. Because we're just copying over a setting node for a variable that doesn't exist here. If you compile, it's going to scream at you. I think you can also just right-click and create that variable, which also is fine, but you can also copy paste them. Now, with those set up, we can use our meta save variable, get the save files map that we have made, and we can add something to that. And the wonderful thing here is with maps, when you try to add an entry that already exists, it just overrides it. So you're not going to have duplicate entries, because it can only have one entry for a very specific key. So it's just going to override it. And if it doesn't exist yet, it's going to add it. So it's actually like very, very, very nice functionality. Both of these branches, of course, are going to add something too. So we're going to try to add an entry for the game that we just tried to save. So let's get that value and put it into the adding node. And then the values themselves, let's split the structure pin, are just going to be, in this case, our game time and our score. Just whatever metadata for your saves you need. You can just put in here. And after you've done that, we can save game to slots. Save game object, of course, is going to be our meta save, now with our newly added save file to our map. and the name will be metasave, which again, I'm just going to copy paste here. Now, one last thing that we do need to do is we need to go into our save menu, and whenever we press the save button, we want to, of course, save the game, but now we need to also regenerate the entire save stack because we're displaying metadata about that save. And after we've updated that metadata, we need to refresh the entire save stack. So in there, we have our bind to on save button clicked, and then we just like we have the save game to that, but we're also going to want to get our save slot stack here and reload, which I misspelled as red load, of course, our save stack. And now, if we play the game again and I open the save menu, you can see that this has the game time and the score on each and every one of them because they're default values. You will note that I won't be able to load from them because if a save slot doesn't exist, you can't load from it. So you probably want to have some visual indication for that as well. But if I now add a couple of score points to myself and I click this, you will see now we have score 10 here, which I also misspelled. Add a couple more. This will be 15, and if I now open the loading menu, I can see, okay, let's load this one with a 10 score, and as you can see, our score again is down to 10, then saving here 28. So now we have a system where we very, very easily can add in metadata to our save file, which again, we have like 90 some save files here. So that should probably be quite enough for any player. As a little bit of a bonus, I do want to show you how to set up a game time counter as well, because I just think that's a fun thing that for the most part doesn't take that much time to actually implement and will be fun for players to be able to see. So let's do that real quick, because we have in our game instance already the game time variable, which we made before, and we're going to very simply just on init, which is the event pretty much equal to begin play for your game instance. We're going to set timer by event. And that event is going to be a new custom event that we made. Just like add game time. And it's just going to run once per second and it's going to be looping. And all that this is going to do is it's going to take the game time and it's going to increment it. And now we simply have a integer that keeps track of how many seconds of game time we've had. I also do want to make a function to, because this is just going to keep track of the seconds, right? We want to have a function that returns the hours, minutes, and seconds. You can return those as integers. I'm just going to be returning those as string values. So let's make a function for that. Get game time string. And we're not going to use the game time value here directly. What we're actually going to do is we're going to make that a input here. So if we make game time an integer input, we can reuse it in different places, because we're also going to need to use this to take the game time integer from our metadata and put it on our save slots. And of course, that's not going to be using this exact value. That's going to be using the value from the metadata. We'll then add a return node, which is going to, like just giving it like 3 outputs or 2 outputs. This will be hours, minutes, and we'll also add hours, minutes, seconds. And then if you want to, you can also make a just minutes and seconds. I will stick with 2 of them. And those are going to be string outputs. So how do we get a seconds value and turn that into hours and minutes? Well, with math. So the first thing we do is we get our game time and we divide it by 3600. This will just take your seconds and turn them into hours. And we'll return an integer because we're not working with floats here. That's why it is important that it's an integer. So it's always going to floor them down. So if it doesn't have like enough value, so if you're at 3,599, it's still going to be returning 0 because it's always going to floor. It's only going to be returning 1 here the moment you're at 3,600 or above. And then it's only going to be returning 2 if you're at, what is that, like 7,200 or above. Anyway, we want to change that to text from an integer. And if we open that up, we get a couple of values here. So we can use some grouping if we want to. We actually don't want to in this case, I don't think. And the minimum amount of digits is going to be 2. That way it will display a nice 0, 1 instead of just 1, which is a little bit ugly. And then maximum digits is not really relevant. That's going to go into a append string node, which we've been using quite a lot in these last 2 videos, into the first slot here. So now we have our hours. Then we'll add in colon, and now we need to get a value for our minutes. Luckily, that's just as easy. Instead of dividing, we use modulo, which is just divide by a number, and instead of getting me the division, it gets you the remainder. So if we're at like 3500, this will still return 0 because you can't divide 3500 by 3600. So this will be 0, but with modulo, it will give you the 3500. So let's say that this is at 5000. We're trying to divide 5000 by 3600. That's going to return 1 because 3600 only goes into 5000 once. But that leaves you with 1400 value over. So that's what modulo will return to you, is it will give you the remainder of any division operation that you're trying to do. Now, that still gives you the remaining seconds, which don't go fully into an hour. So from there, we simply can divide that by 60 to get a value in minutes, which again will always floor down. So it will only count 4 minutes here. And for the seconds, you can probably already tell we're going to use a modulo for 60 as well. And this will then eventually give you only the leftover seconds that don't fit inside of a minute or inside of an hour. But we'll get back to that in a moment. We'll use the same to text for this integer and put that in the bottom one for this appending node. And that's going to be our hours and minutes return. Now, we pretty much just take that and append one more thing to it, which is going to be our seconds. If we append that to there, now we have an hour, minutes, and second. Again, if you just want a minutes and seconds, you make one that doesn't have this top one. So you only do the things that are on the bottom here, and you will have a minutes and a seconds counter without the hours in it. Just for fun, I'm going to make a quick little widget blueprint here, which will just be like game timer. We'll make that an overlay with just a text. The text I'll outline to the exact middle. That's fine. And here we need to have a way to update this timer, which actually, let's go back real quick and give this a default value of like 000000. But we need to have a way to update that string every time a second goes by. So in our game instance, we're jumping a lot back and forth in this. I am aware there's not much you can do about that, sadly. There's just this code is spread so far between different objects to make it like work properly. But here in our timer event, so this runs once per second, what we're just simply going to do is an event dispatcher on time updated. And this will take in a integer for time. You can call it new time or whatever. All that matters is that it takes in an integer. So when we call this, we can give it the new time. So now it will also have an event dispatcher on the game instance that pretty much anything in your game that needs to run on this like 1 second loop can just listen out for this event dispatcher. For the most part, that's just going to be those little counters. But like if you have something that needs to do something once a second or whatever, this is a very easy way to set that up as well. Anyway, in the game timer on event construct, we simply get the game instance. We've done this a million times before. We cast to our blueprint game instance. We assign on time updated. This will give us our new time. We already have our game instance here. We can use our get game time string value, which is just going to take in our game time and return our hours and minutes or hours, minutes, seconds. We're using hours, minutes, seconds here. Make sure to hook it up to event construct as well. So we simply just need to set our text here as a variable so that we can use it in the event graph, set text, and we'll be setting that to the hours, minutes, seconds. And now we have a counter that we can pretty much add into any UI that we want, and it will always be displaying our current game time. So let's add it to the save menu and the load menu real quick, just because it's fun. So our game time widget, add that to like the top left or something like that, and we'll anchor that to the top left, and we can just copy that, and then in our save menu we'll paste it in as well. So that should now show our game time. It's 3, 4, 5, 6. So what you might want to do is in the event construct, when it is constructed initially, maybe you also want to run this event once. So on time updated event, we simply get the game time so that it doesn't show that 00 for like half a second when you initially open it up. So now we can see immediately it shows the proper time. Doesn't quite show the time yet in the game files here. We can quite easily change that. Now that we have this entire thing set, we can go into our save slot stack here, and where we, again, don't worry, the project file download for Patreons and YouTube members is going to be a little bit less messy. I'm going to clean this up. The default game time, by the way, should definitely read as 000000, and then setting the game time, instead of just taking the game time value out of the metadata, which is just like one integer. It's just one value. We need to check whether or not we have a reference to our game instance yet. We do not, so we will... let's do that at the start. Let's just make it a variable. Get game instance, and we will cast that to our blueprint game instance. We've done that about 1 million times now. I'm sure that you get the point. And we will promote that to a variable so that we can use it right over here. So now we have that game instance, and we can get game time string, which actually, because there's no execution happening in this at all, it's just input output, we can very much make this a blueprint pure node. That will break something in the game timer that we just had. Oh no, it actually automatically relinks everything. It makes it one of those green nodes, so you don't need to have an execution pin in order to use it, which is quite nice. So that just takes in any integer and returns our hours, minutes, seconds, which is going to go in there. And now when we try to like save or load a game, you will see we have 5, 6, 7, 8. We save the game, and it properly displays the game time from when we save. And when we try to load something, our save time should also go back to where it was at. It doesn't instantly do that because it doesn't instantly message that through to the game timer. That's specifically only relevant for the load menu. I suppose on the load menu, when we load the game, what we could do is we could say, hey, the game timer that we have here, we can run the on update event so that it automatically gets the proper value with then the game time from the game instance, just to make that a little bit more snappy. Now we effectively have cloned my entire save system. So we can see we're at 2, 3, and immediately it goes to 9, 10, 11. So it's been a little bit longer than I thought. I thought I was going to make like a quick fun tutorial about how I set this up. It ended up being 2 parts. When I edit this down, I might actually edit it into 3 parts. I don't know. We'll see. So if you want to support this channel and these tutorials, do go down below in the description below. There's a Patreon page and a YouTube member link. It's not in the description for the YouTube members. That's just like a button somewhere in the YouTube watch page. You know how it works. And supporters there can get the project files for this entire system. Again, I'm going to clean it up a little bit because it is quite messy at the moment with like a little noodling around. But you can get those if you are a supporter on Patreon or as a YouTube member. So thanks for watching. Hopefully it's been helpful. It's, again, a quite intricate system in many ways, so there's a lot of elements that come together to make this. So do feel free to go back over and watch the entire thing again if there's anything you missed. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,